Good morning, everybody. Thank you very much for taking the time to join today's webinar, where I'm your host, Wes van Deventer, the current business manager at ShopCare. And then we'll also got our esteemed speaker today, Brent Sutton, who is an extremely experienced individual when it comes to health and safety and well-being. And he's got a real passion for machine safety as well. He's been giving us a bit of time from his point of view to share some of his machine safety experience in this series, and we are very grateful for him to share and try to build that community with us. Saying that, just before we kick off, guys, I just want to let you know that all mics are on mute. If you want to make any comments, just use the chat function. If you have any questions, use the Q&A function at the bottom. If there's any issues, let me know, as well as the chat. I'll be monitoring that. If we've got the capability at the end, there's some time, we can potentially open the lines for some live questioning. But other than that, just try to stick to the Q&A as well as the chat functions, which I'll be monitoring. Further note, guys, just next week we will be hosting another webinar, and that webinar is Falling Asleep at the Wheel: How Fatigue is Killing Our Drivers, Machine Operators and Workers. That's on the 17th of November. Please don't miss that one out. That one is going to be really, really interesting. And we've got another one with Kelly McCluckey regarding chain of responsibility for supply chains. And that's happening on the 29th of November. So watch out for those and make sure that you register early to be able to join. I think that's also going to be a great one because it's trying to really build that chain of responsibility within New Zealand. And we know that's coming for all our transport and heavy vehicle industry. Then lastly, guys, today is the first webinar of 8. Please make sure that you don't forget to register for the other 7 with Brent. These are quick, short 30-minute webinars, which I believe is very valuable, and it's also not too big of an investment to make on a daily basis. And then just as a quick note, I know Brent's going to talk about this a bit more a little bit later on, but the new plant regs is coming in soon, and I know he'll be talking about that as well. And then just before I go, guys, potentially there will be one poll question at the end, just depending on if everything works properly. I'll try and add that question at the end. But without further ado, thank you again, Brent, for taking the time today and joining us and sharing some of your expertise with us. I know it will be a lot of value, and I'll be in the back and I'll be monitoring all chats. See ya, guys.
That's great. Hey, look, thanks, Wes. And look, thank you, everyone. I recognize some names, so thank you for those that have come back for some more punishment with me. That's always grateful. And hopefully everyone can see my slides. Look, I think what Wes said is true. I am passionate about safety, and the reason I'm passionate about safety is that I keep seeing the same issues happening time and time again. And it's really about understanding that relationship between humans and machines. And in this series, imagine this series, the reason we've created this into 8 different modules, it's about, think of them as building blocks. So today's session, is really the start of that building block. We want to get some of those foundations built in, but as we progress, we'll be able to build on that. And this series, we're going to make, this content available. I'm also going to provide with you some really useful handouts and other information across those modules as we go. So let's kick off. And what we do need to recognize is that this building of community and getting the word out, this came about as the result of an enforceable undertaking with an organization called Daikin Southland Limited, who manufacture high-grade MDF. And they had a serious injury affecting a worker a number of years ago. And part of that enforceable undertaking was for them to try and build industry knowledge around machinery safety. So thank you, Daikin, for that. And we're going to cover this across 8 different modules. And today's module is we're going to explore trends of machinery harm. We're going to be looking at the life cycle of machinery and also around the duties and responsibility of duty holders itself. I'm not going to try and make it too boring around the duty holder responsibilities. But I think there's a really interesting conversation to be had about the new plant and structures regulations that are coming in. So what do we know? The fact is this, that we've had in legislation since 1950, legislation that is specific around machinery safety. And the Machinery Act of 1950 got repealed in 2015. So from 2015 until 2023, there has been an absence of regulation around machinery, which I think is quite disappointing. And even if I look back to what the Act of 1950 said, a lot of those things are still very reflective of today and what people are facing. I think what has changed is the growth in the area of automation. And in a later part of this webinar series, we'll be exploring the different types of risks that exist in automation versus a lot of the current sort of manual interfaces between people and plant. For whatever reason, we actually think that automated machinery is safer. I would challenge you that automated machinery is able to exert much higher levels of harm. I think it's the opportunity of harm that is different. And the fact is that plant and machinery still continues to be a major contributor to harm in this country. And if we look at the prosecutions that are going through the courts, probably 65 to 70% of those prosecutions are around machinery. Yet the causes of those things is still very much similar. And that leads me to the conclusion that our risk management of plant and machinery is still not being managed well. So here's the good news. There is a great opportunity for us to do better. And when we think about machinery harm, there are really two trends. There's the trend coming from about the risks from the plant and machinery itself. And there's also the risks that come from the life cycle of that plant and machinery. So let's explore the risks from the plant and machinery itself. So these are the top 6 items that are featured in prosecutions. Shockingly, workers still being able to reach into dangerous parts of the machine. And when we think about reach, I want you to think about in your head, think about the human, think about the ergonomics of the human. Think about people reaching through, people reaching over, people reaching under, and people reaching around into machinery. The second highest thing was guards not securely fastened or easily removable. I still see stuff being taped down. I still see guarding with wing nuts. I recently saw some interlocks that were held together with bungee cords and straps. None of those things are fixings. Things that fix guards are things that need to be permanent by their nature, not temporary. So the third component was opening of the guards. In other words, the guard wasn't preventing the total reach into that danger zone. So when you think about that, think about the gap that exists. And for example, a gap of about 6 millimeters can allow a finger to enter. A gap of 20 mil can allow a hand and part of the arm to enter. Or a gap of 180 mil can actually allow a whole body to enter. The next thing that came through was that interlock guards could be opened whilst parts were still moving. Sadly, I see that quite frequently with light curtains themselves, where if an object activates a light curtain, that the actual machine should come to a complete stop before that person is able to reach that danger zone. So there's still quite a bit of stuff where those guards, those things that we're relying on, those higher level controls that are supposed to bring the machine to a safe state, that workers can access those zones before the machine gets into a safe state. Number 5, your safety switches can be removed or overridden the guards. That one is really interesting. I would say that that is a hangover of very early types of technology, of early different types of safety switches. Things like limit switches, things like magnetic reed switches, those types of things. The modern safety switches, the interlocked, the sort of category 3 type switches, they don't allow humans to be able to defeat them. If the switches are disconnected, the machine cannot function. If the switches aren't joined together, the machine cannot function. They very much what we call fail-safe type devices. So a lot of that is really old technology. Or what I've also seen recently is where the company has brought some machinery. They were told it had these safety features, but no, those safety features were removed for lower level type devices. And the last one is the system failure. And that's when things like either the pneumatic or the hydraulic system loses pressure and allows something to fall. So when we think about that, there's still quite a bit of pneumatics and hydraulics used in the food sector. I think, once again, pneumatics, things that are held up by air, is really interesting because there's always going to be multiple failure points around that. So the 6 items head into there. The life cycle of machinery is always fascinating because what WorkSafe are trying to do is they're basically trying to share with us that the risks around machinery change during the life cycle of that machine. And that life cycle can be everything from the design, procurement, and due diligence, all the way down to the storage and the decommissioning of that machine. In my view, the most common ones that I see really sit into these 4 main phases. So the setup and adjustment component for the machine, in other words, the things that we do prior to the operation of the machine, the different types of hazards and risks that are present during the running of the machine, and the different types of hazards and risks that are present when we're trying to clean the machines. And the last one, the different types of risks that are present when we're trying to clear jams or fix the machine on the fly. And when I say fixing, I'm not really talking there about general maintenance. I'm talking there about having to make adjustments or changes, particularly with older machine. So that machine may have a particular set of hazards, but across those 4 modes, those hazards will be present at different times, and the potential for those hazards to cause harm will also change during those modes as well. And when we look at the type of things that are coming through around those prosecutions around the life cycle, that workers are able to remove guards for maintenance and not replace them. Interlock guards can be open while parts are still moving, particularly around cleaning. The 4th one, which comes as a surprise, but sadly I've seen it before, is that interlock guards is used as a shortcut to start the machine. So if we think about that, an interlock guard should perform the same function as an emergency stop. So when that guard is removed, it should initiate an emergency stop, meaning that the machine cannot be restarted until that stop function is reactivated and the control panel comes back online. What I see quite often is that some of these features are actually initiating a pause on the machine rather than an emergency stop. And the next one is the over-reliance of lockout tagout. I don't think there's any shortage of New Zealand organisations with a lockout tagout procedure. I think there's a really big difference when lockout tagout is used for routine operations versus non-routine operations. There continues to be an over-reliance of lockout tagout being used for cleaning of machinery. And could you just imagine, I was at a facility recently where the machine line had 28 different isolating points for that machine. Cleaning the machine only took 30 minutes. Isolating every point took over an hour. So if workers are being pushed for production, or the organisation is trying to get things out quicker, which bit is going to go? The cleaning of the machine or the hour it takes to initiate all those lockout tagouts? So from my point of view, when I think about that, we should be engineering the machines in such a way that when they need to be cleaned or when jams need to be cleared, that the design of the machine removes that source of energy to begin with. Because that's what routine operations are about. The sixth component was about the machine being modified to perform other functions. You know, New Zealand companies are really good. We'll take a machine and we will make that machine do many, many things that it was never designed to do. And somehow we call that innovation. So when we take that machine and we design it for it to perform other functions that it was not designed for, how do we know that we're not creating some or sort of breaching some sort of prohibition? In a recent case, we had an example where in a construction environment, the workers had to perform a job of what's called undercutting. So when they're fitting flooring to properties, they need to trim the skirting board or undercut the skirting board so that the new material can be laid for the floor. And this group had diligently taken an angle grinder and they had modified the angle grinder with a guide so that they could replace the cutting disc with the angle grinder with a sawtooth blade, and they could place the angle grinder on the ground and cut along and make a very clean cut. Well, the problem here is that although angle grinders can be used as a cut-off, there is a prohibition around the use of sawtooth blades. Why is there a prohibition? Well, angle grinders are dangerous with kickback at any time, but the risk of kickback with a sawtooth blade is far higher. So in that sad situation, what happened? They're cutting back. They hit a piece of metal strip in that cutting process. The angle grinder kicked back and the blade embedded into another worker's arm, causing major harm. And the seventh component, which I think links back in, is the absence of change management. That as we change work, as we change work design, as we change the materials used on machine or how we perform that function on machine, there's not a lot of thought around the change management in terms of the types of risks that the workers are being exposed to on that machine, because we believe we've already identified the risks. And it may be that the hazard, for instance, it may be that there is a hazard of crushing or that nip point. But what does change when we change that work design is when that worker is present to that risk. So the hazard may have already been there, the hazard would have been well known, but when they're exposed to it, has changed dramatically for that worker, and that wasn't picked up in the change management process. All of these things are underpinned by our legislation. And as it stands at the moment, there are a series of duties in the Act itself And the notion of what is reasonably practicable at the moment is very much driven by the joint Australian and New Zealand standards called AS/NZS 4024. So let's explore some of those things. The Health and Safety at Work Act makes it very clear that as part of a supply chain arrangement, that different parties in that supply chain have a duty to ensure that the machine is made safe for its intended use, and that they provide relevant information to the PCBUs that are going to buy the machine or use the machine around its safe use. I don't know about you, but I am yet to see anyone who designs, anyone who manufactures, anyone who imports or supplies, I have yet to see any of those people being prosecuted. At the moment, it is the people that manage or control the plant and machinery that are being prosecuted. I don't know why. I think it's way overdue, because what I observe is that there is a disparity between small businesses and large business around machinery safety. Small businesses are totally reliant on the supplier or the installer or the commissioner of that machine to make sure that machine is safe. And I've even seen it to the extent where these organizations have issued these certificates to companies to say that the machine has met AS 4024. Yet in a short space of time, a worker has been harmed as a result around that. WorkSafe are looking to effect change in this space, and there are the proposed plant and structures regulations that are before Cabinet at the moment. And my last update, which was about 10 days ago, is that we're expecting to see those regulations come into play early next year. Well, what does that mean? Well, I think the good news is that the plant and structures regulations will provide much better clarity for organizations around what is expected of them. The other good news is those proposed changes around the plant, particularly around machinery, those changes are consistent with the joint New Zealand Australian standards of 4024. So if you've got machinery now and you're following 4024, then these new types of regulations aren't going to be adding to you. On the other side, these regulations allow the regulator to be able to impose a different set of powers. So right now, if the regulator comes into your workplace and they observe something with a machine, they have a set of powers they can invoke, such as issuing improvement notices or prohibition notices. And they are more likely to prosecute as the result of an event rather than as the result of some type of normal visit. The regulations in this case are going to give the inspectors an additional power. And I think what we'll see is where, if we think about the components of engage, educate, and enforce, I think what we'll see there is where there is repeat conduct of that company around machinery safety, then the regulator can use the fining elements of the regulations where they can issue instant fines as that deterrent or as that enforcement action. Because prosecuting is expensive and it takes a long time. So I'm not sitting here saying that I'm a proponent to this, but I think it is useful that a regulator has a kit of different types of engagement education and enforcement actions at its disposal. And given that I continue to see the same things happening time and time again, maybe it's time that we took a slightly harder line.
A quick question, sorry, Brent.
Sure.
Matt just shared a link and is regarding the manufacturing organization being fined as well in New Zealand. It is, I just want to quickly open it back up. Give me 2 seconds. It was in stuff and it happened in May. Well, the article was in May 2019. Christchurch Firewood Company to pay 110,000 after workers' fingers sliced off. What is interesting, it says here the manufacturing of the machine, MMD Engineering Ltd, was fined $60,000 in order to pay prosecution cost of $2,300.
Yeah. So I think once again, what you could take from that is that the PCBU who was controlling or managing the piece of plant carried a higher culpability rather than the manufacturer. But at the same time, if I took a cynical view, in both situations, they would have to take into account the financial means of the organizations as well in that space.
Yep.
So yeah, so look, thanks for sharing that, Matt. It's not one that I was aware of. And removing a guard from a log splitter. Well, there we go. Isn't that great? What puzzles me is you can go out and rep one tomorrow as a home user, and no one gives you any training or puts you through any induction process or does any type of assessment around safety. But that's okay, as long as they split logs and not split hands. So at the moment, the notion of reasonably practicable when it comes to machines and machinery safety is very much centered around the Joint New Zealand Standards, or the series called 4024. Those standards are derived from the European standards. And in Europe, they're often referred to as the EN standards. And those standards were created for designers. They've been created for engineers. They're not a particularly friendly document. And I think at the moment, the biggest bugbear is that those standards have to be paid for. And those standards also are updated every 5 years as well. And what I wanted to highlight to you is there are 4 main series of standards that are applicable around machinery. So we've got the series of machinery safety standards themselves. We've got the standard around platforms, walkways, stairways, and ladders. We've got the standards around noise, and we've got the standards around lighting. And all those things work well together in that space. When we look at 4024, what we find is that it's a layered approach, and that there are 3 types of standards that exist. Commonly referred to type 1 or type A, it is a generic standard. So for instance, there is a standard for how you should undertake a risk assessment with machinery. And that standard, it's not telling you what colors to use. That standard is not telling you what risk model to use. What that standard is doing is it's informing you around what are some of the risk factors that you need to consider around machinery. So for example, it says that when it comes to physical harm, that acute harm for workers, you need to understand the relationship between the hazard, the thing that can create the harm, and the workers and the work that they perform. So those guidelines are really useful at describing a good risk management technique or concept to follow. It doesn't say this is the model to use or these are the lovely colors to choose. But in that standard, there is language that is used, and this language is not normal language that we use in health and safety. And I wanted to share this with everyone because it's really useful language to talk about, because it really can alter our perspective of safety in other ways. So let's explore that language. So the first thing that they talk about is danger zone. And with machinery safety, it's not so much you're trying to find the hazard, you're trying to identify the danger zones, the zones that people can access. And a danger zone is any space within or around a machinery in which the person can be exposed to the hazard. So once again, it goes back, what they're talking about there is you think about the human, you think about the job they're performing, and you think about how they can reach into or around or through or under in that environment. The second component is this notion of reasonably foreseeable misuse. How often have you heard of an event where the worker got hurt and the response of the company is that they ignored the sign which said, "Don't put your hand in the machine"? I've got no idea what the sign's meant to do. And reasonably foreseeable misuse is that. What they're saying there is that the use of the machine was in a way that was not intended or anticipated by the designer, but can occur from predictable human behavior. So the machinery safety standards are basically really telling us that put human error aside, because that's not relevant. It's about understanding predictable human behavior from normal everyday work. So if those workers are having to get close to that danger zone to perform their normal work, then it was reasonably foreseeable, and that should have been managed by the organization. So when people say to me, "We put a sign up," I said that does not meet the notion of reasonably foreseeable misuse. The third word is safeguard. And in machinery language, a safeguard is a guard, a fence, or other types of protective devices. They are physical things, and they are physical things that keep people away from the danger zones. And those safeguards, as we'll explore in a later module, actually have a hierarchy. And surprisingly, guarding, like fixed guards, aren't the default in that hierarchy. Yet there is an over-reliance of people fitting guarding to machinery. But the standards don't start with guarding. They talk about the use of safeguards. And what they link to that is that if we implement a safeguard, we also need to have what's called a complementary device. So these are things that support a safeguard, i.e. beacons, audible alarms, markings, labels, and signage. When I talk to organizations, they see those things not being complementary. They see those things as being primary controls. In machinery safety, they are not primary controls. They are there to support another control. So if you think about your machinery, anytime you see flashing lights, you've got beepers, you've got markings, you've got labels, ask yourself, what are those things supporting? And I think you might be surprised what they are supporting. So, questions. What are people's thoughts? This is your time to share. I'm quite happy, Wes, to go open mic, cameras, whatever the case may be.
Thanks. Guys, quickly pop the questions through to And while we're waiting for those questions to come through, I've got one poll question for you all, and I would really appreciate your participation. This poll is anonymous, so please feel free to answer honestly. The poll question is, has this webinar been of value to you and to do things differently? Yes, I found that of value and will do things differently. Yes, great to obtain confirmation of what I already know, or no, I didn't learn anything new. And let me see if I can open up some of these lines. Please, guys, feel free to ask any questions. You want to ask a question to Brent or myself, just unmute yourself before asking the question. And majority of you are live as we know it. Unfortunately, I have to do it all one by one. We only got a few minutes, guys, before the session's over, so please make sure you use this time wisely.
Don't be shy. I won't call anyone out. And there's no such thing as a silly question. Please just be curious.
Yep. Just interesting, I must be honest, Brent, on your discussion today and on different layers in the language. You know, I think there's definitely a lot we can learn from there.
Yeah, and the crazy thing is, machines can only harm you one of 7 ways.
Yep.
If we understand how they harm you, it puts us in a great position to do better.
Oh, definitely, definitely.
You know, machinery is not complex. You know, machinery by its nature is you know, it's binary. I think the relationships with people and machinery, that's complex. So whatever we can do to manage the source of the risk, the hazard, we have to do less around the human.
Yep. Agree. We've got one question here from Matt Jones. Where do you see emergency stops fitting in the control hierarchy? Perceptions versus actual.
Well, so the fact is, every machine must have an emergency stop. And that emergency stop must be within easy reach of the operator. And emergency stops are there as a response and recovery control to a problem that is present. So they are not about preventing harm. They are designed to reduce the level of consequence from exposure to that harm. The biggest thing I see with e-stops is that they are used by people and by the organization to pause the machine. They were not designed for that purpose. Yeah, they were designed there to initiate an emergency stop. And when someone initiates an emergency stop, the organization should actually be proactive and find out what were the conditions that existed at the time where that worker felt they had to do that. Whereas what I commonly see is that the organization responds and saying, you know, why has the machine gone down? So we need to shift our thinking, because how we respond to those things really matters, because workers are only using it. Remember, I call it, it's the last line of defense. It's that last line of defense. And if we discourage that use, then that's going to complicate things.
Totally agree. Totally agree. Hopefully that answers your question, Matt. Guys, time for one last question before we close off. I'll give you a couple of seconds just to see if there's anyone else that want to pop up with another question.
Or even if the people attending feel there's some other topic they want to include around machinery as we go along, I'm more than happy to take that feedback and to build that in. At this stage, I'm just trying to help sort of scaffold and build that knowledge over time for people.
No, I appreciate that. I appreciate that. Well, I think that's more or less for today, guys. If you've got any further questions or comments, like Brent just mentioned, anything else that you think he needs to look into from a topic perspective for machine safety, let us know. One last question. I think we've got about 2 minutes or so. Is there any portal to access standards free that you know of?
No. That's a huge problem, isn't it? No.
It is. It is. No,
Yeah.
definitely is.
It's disappointing.
Yeah. All right, guys, thank you very much. Make sure you don't miss the next one. Make sure that you go register for a part 2, which I believe is in about 2 weeks' time. So make sure that you get your copy of that. This event will also be available to you live, well, not live, but on our channel in the next couple of weeks. So if you want to rehash this session, you will be able to get access to it. Thank you, Brent, yet again for taking your time and sharing your expertise. Thank you, everybody, for coming along and participating. And I know your time is valuable. And I hope to see you all at our next webinar. Until then, take care, stay safe, and see you then. Bye-bye.
Thank you.